Hi students. So here we will discuss magnetic effects of current part 7. Already I uploaded part 1 to 6 no. Please go through it all the parts no. Then come back to the part 7. So which is most important no. So we'll see in this part 7. So we'll discuss one more important concept, that is magnetic moment. Right? What is this magnetic moment now? Magnetic moment. Most of the times no, they are asking this question. So in the NEET and JEE-MAINs no, most of the time these questions are repeated onto this. What is a magnetic moment, right? So magnetic moment of a coil, right? So like we already studied dipole moment in our electrostatics. We studied dipole moment, right? So dipole moment is nothing but a charge into length. The dipole is there is a positive charge and negative charge is there. Here magnet will be having positive, I mean like north pole and south pole onto this. So therefore is a magnet is nothing but it's a dipole, because it is having two equal and opposite poles onto this, right? So magnet is nothing but it is a dipole only. Therefore for this one also should have magnetic moment onto this, right? So what is a magnetic moment here now? What is a magnetic moment is defined now? Even not only for the bar magnet no. So this is a bar magnet is there. It is having north pole and south pole. So it is generally we can write down like a small pole strength no. Magnetic moment is denoted as pole strength into the distance between these one no, that is nothing but 2L. Right. Similarly, a current carrying coil, so circular coil or any type of one coil is there no. Therefore, so one side, therefore field lines are entering, another one no, field lines are leaving onto this, right? So one side it will be like a north pole, another side of this one no, it will be act like a south pole. A current carrying coil is also nothing but a magnetic dipole no. For this also some magnetic dipole moment will be there. What is a magnetic dipole moment now? Magnetic dipole moment, how to calculate it now? So number of turns into current into area. This is most important formula. So magnetic moment, what is a unit now? Unit of this one is number of turns. So current is nothing but ampere into area is nothing but a meter square. Ampere into meter square is the unit, right? So SI unit. So therefore dimensional formula here now. What is the dimensional formula? L square into A. So this is your dimensional formula. Is a vector or scalar? So you should question yourself no. Area is vector or scalar? Area is a vector quantity. So here area is there no. So here magnetic moment is a vector quantity. Therefore it is a vector. How to find the direction now? Direction you can find it like a area. That means perpendicular to the plane of the area. We'll see. We have to use right hand thumb rule only. Let us see. Right. So magnetic moment is defined as, for a bar magnet, pole strength into the distance between the two poles. Right. Like our dipole. We already studied positive charge no. So negative charge separated by small distance, it is nothing but a 2L. So dipole moment we can rewrite it as Q into 2L. Like that. So bar magnet is also a dipole, therefore the dipole moment is nothing but a pole strength into the distance between this one no, is 2L. But current carrying coil is also a dipole. For this one no, magnetic moment can be defined it as like a number of turns into current into area. So therefore dipole moment is nothing but a vector quantity, right? So what is the direction of this one now? Therefore you have to use right hand thumb rule to find the direction now, right? Let us see one simple applications on this clearly. So suppose there is a one circular coil is there. This is one circular coil. So this is the current here now. Current is I. So therefore here the current no. Therefore a current is there. Therefore here you have to use right hand thumb rule. Current direction. Current curling of this one of fingers is nothing but current direction. Thumb indicate the direction of your magnetic moment. Therefore this side it will be a magnetic moment. So what is the formula here now? Number of turns into current into, if it is having the radius is R. Radius is R, that is nothing but a pi R square will be your dipole moment of your current carrying circular coil. Even in all the situations no, you have to calculate the area only. So this is one square coil is there, therefore here I. So current is flowing here no. So therefore square coil of length is L. So what will be the magnetic moment now? Magnetic moment is nothing but a number of turns into current. What is the area of the square coil now? Square coil is nothing but a L square. So what is the direction here now? So current is like this. Therefore current is like this. So current is now. Therefore the magnetic moment is into this one now. Clear? So this is your magnetic moment of your square coil. Now equilateral triangle coil, so this is now, so here this is a current here, no, current here I and I, so length is L, equilateral triangle, no, again the same story, same thing. So what will be the formula here, no, magnetic moment, it will be equal to N into I into area of the equilateral triangle, therefore root 3 by 4 L square will be your area of this equilateral triangle. What is the direction here now? So current is flowing like this, therefore this is your direction now. Clear? So now equilateral triangle, no, now like this, so we can calculate, so what will be the magnetic moment of a regular hexagon. This is regular hexagon. So remember that regular hexagon now, so regular hexagon, so this is having current is I, length is L. So regular hexagon is nothing but a, so it is combination of, okay, you can see it now, 1 2 3 4 5 6, so it is nothing but a 6 equilateral triangles. Clear? So of side it is length is L. So what will be the magnetic moment now? Magnetic moment, it will be equal to N into I into number of turns, right, into, so what will be the area of the equilateral triangle? Root 3 by 4 into L square into 6, so will be your magnetic moment of this one now. What will be the direction now? So direction is into the plane of this one now. Clear? So like this you can calculate the magnetic moment of a different combinations now, right? So now let us see one more JEE-MAIN question, no, recently it is asked, no. So this is one coil is there, this is one coil, so like this is just it is finding the area only is more important here, no, right? Let us see here, no, this is one square coil, this one coil is there, no, therefore it is designed like this. Now we have to calculate, this is your radius is R, this is the current is I, current is like this, therefore here, so we have to calculate, so number of turns here, no, number of turns is N, so we have to calculate the magnetic moment. What is the magnetic moment now? Number of turns into current. What is the area? Area is nothing but a, this is one semicircular coil. Semicircular coil means what? Area of the coil is nothing, circular coil is nothing but a pi r square, but semicircular is nothing but a pi r square by 2. Therefore here how many semicircles are there? 1 2 3 4, so 4 into pi r square by 2, and this is also forming like one a square of radius is of length is nothing but a 2r plus 2r whole square. You understand, no? Clear? So you can write it as N into I into, therefore this will be 2 pi r square plus 4r square will be your answer, no? So in this way you can calculate the magnetic moment of this one. You understand, no? Even so one more combination, no, you can rewrite it as, that is suppose a current therefore here there is a one electron is there, no, in our Bohr's radius, no, Bohr's atomic model. So this is one nucleus, so here there is a one electron is revolving now, right? So one electron, what is happening now? It is revolving in a circular orbit of radius is, suppose it is r, right? So we want to calculate the magnetic moment of this one, no? Therefore if you know the velocity, so we can calculate the velocity, radius, all and time period in a first orbit, no, by using Bohr's atomic model. So when you are discussing the atoms, no, at that time we will discuss this concept, no. Now let us assume that electron is moving in the with the velocity is v. Electron is moving in this direction means, so current is flowing in this direction. This is your direction of your current. Clear? So be careful now, don't confuse on this. Here electron is moving in this direction means this is your direction of your current. So direction of your current is like this, so therefore current direction now, therefore it is into this one now, you can rewrite it as. So current how to calculate now? E by, therefore time period, time taken now. But we know velocity is nothing but a distance by time, that is nothing but a 2 pi r by 2 pi r, we are taking a small r here, no, therefore by time period. Time is equals to 2 pi r by v, so E by, therefore 2 pi r into v. So this is your current. Clear? So now in this way, so we can calculate what will be the magnetic moment here, no. Magnetic moment is nothing but a number of turns, right? So it's nothing but a frequency here for one time period, no. One time period is nothing but a one rotation here, no. So you can rewrite it as 1 into current is nothing but EV by therefore 2 pi r into, so therefore area is nothing but pi r square, therefore pi and pi get cancelled, 1 r and 1 r get cancelled. Magnetic moment is nothing but so EV r by 2. So slightly we can modify this one, no? What is this one now? I can multiply with m and I will divide with m, no? Therefore what I will get it now? Here m is equals to, therefore mvr, therefore mvr E by 2m is nothing but angular momentum of your electron, no? Very important concept now here. So therefore here an electron, when it is revolving, no, E by 2m is nothing but E by 2m into angular momentum, right? So very important, no? Therefore angular momentum direction is what? So r cross v, therefore r cross, this is your r cross v, therefore this is your angular momentum direction. But here current direction is into this one, no? Therefore magnetic moment and angular momentum direction is in opposite direction, no? That's why we can take it as minus of this. Clear? So most of the students know, they will confuse why this minus, no? So this is the reason. So this is your radius now. See here, this is your radius r cross v. So right, so therefore this is your angular momentum now. So current is flowing like this, this is your into this one now. Therefore magnetic moment and angular momentum are in opposite direction now, right? So here magnetic momentum by angular momentum magnitude is nothing but E by 2m. So this is your Bohr's magnetron, right? So this is also very important concept now, right? So magnitude, sorry, okay, like this. Right? So let us see one question now. So this is one of your NEET question, very important, no? So NEET question 2023 or 22, some question is given, no? Very important. Suppose there is a one length is given now. That length is equals to, so length of this one is like a 12L. What is the length of this one now? It is 12L, right? Now this carrying a current is I. Now this 12L length of the wire, no? What we are doing? We are making this one wire into different shapes now, right? So this wire I am making in the form of like a triangle now, equilateral triangle. So off side it is L, current is I. Also it is making like a one square coil, off side it will be L here, right? It will be L, right? So current is I. Also it is making like a regular hexagon, no? So therefore here off side it will be L. Clear? So this is a current now, correct? So we want to calculate the magnetic moment, right? So most of the students know, they confused here, no? So what is the confusion here now? Therefore here, okay, generally they will write it now. What is the magnetic moment now? We'll leave it number of turns, no? Current is I. What will be the area? Root 3 by 4 L square. But here number of turns, okay, most of the times, no, this they will choose this option. This option is wrong. Why? Because we choose here, that is 12L. Therefore length of this one is how much? No, 12 meters. But we are making now, this is 1 meter, only 3 meters are there. So remaining other one, what happened now? Again we have to rewrite it as now. Therefore this is 1, 2, 3 meter, 4, 5, 6, 2 rounds are over, like that, again 2 rounds, totally 4 rounds will be there. Therefore number of turns it will be equal to 4. Most of the students, they will confuse here, no? They have to write it as 4. So this 4 and 4 will get cancelled, no? Therefore root 3 into I into L square will be your magnetic moment. Like this only we can do it now. Here how many turns will be there now? Number of turns it will become like a, this is 4 turns are there, therefore length is L. So therefore 12 by 4 is nothing but a 3. Number of turns is nothing but a 3. What is the magnetic moment here now? Number of turns is 3, current is I, it is L square. This is your magnetic moment. Here regular hexagon is there, it is 12 sides are there, 12L, 6 sides are there. So therefore 6 and next one is also 6, no? So they totally it will be equal to number of turns, it will be equal to 2. So what will be the magnetic moment now? Number of turns is 2, I into, so here what will be the area of the regular hexagon now? 6 into root 3 by 4 L square. Clear? So therefore here this is 2, this is 3, therefore 2 to cancel now. Magnetic moment it will be equal to 3 root 3 I into L will be your magnetic moment of your regular hexagon now. Clear? So like this, So this is one of your NEET question, no? So most important, most of the students are confused how to calculate the number of turns, no? Right? Please be careful onto this one, no? These type of concepts, no? Now we'll go for torque motor effect. So motor, right, effect, no, or principle involved with the motor. Therefore this is one, we'll take it as like a one north pole, one magnet, no. So how the motor is rotating, no, north pole and south pole. So this side it will be your magnetic field will be there. So what is the magnetic field now? Magnetic field will be always from north to south, correct? So this is your magnetic field now, clear? So in this one, no, there will be one coil is there, no, this is one coil, right? So this will call it as like a armature, no. This is one coil, a current carrying coil, no. This coil is placed on a one shaft rod, no. This is one rod. So this rod, it will be able to rotate it. This rotational motion we will be utilizing this one now. So here what will happen now? Here we want to make the current to flow in only in one direction now. So for this one now, what we are going to do? We are going to take it as like a one split rings onto this rings, no. So for this one now, why? So then from this split rings, no, for these rings, no, what we can do it, no. So we can connect one battery here now, right? So that the current it will be able to flow. Current it will be able to flow every time the same direction. Why? Let us see this one now. See here. So here initially the current is flowing like this. The current is flowing like this. So this is a current. So this side it will be a field. So therefore it will be force is acting now. So it is inside the force is acting onto this. Force is acting into this one now. And so current is flowing here now. Therefore here the current is flowing onto this. This is a current. So this side it will be a field. It is outward. Therefore, so this part is experiencing outward force. That means you can try to see that now. This side part, no, it is experiencing outward force. This side part, no, it is experiencing inward force. When it is getting turned onto this one, no, so again the current direction which should be becomes like a same. If not, the current direction, if it is coming here, no, when this part is comes, no, current direction like this. That means what will happen? Again this part comes, no, the current direction is also upward direction. Therefore, what will happen now? Upward is there means again it will be able to turn. That means, so why we are making to make the direction to flow in one direction means, so when it is coming here, so again it will come here. We can come here, again coming it will be here. So we don't want like this. We want to have full complete rotation, no, such that when this part comes here, no, current direction should be in this direction, no. For this purpose only, we will take it as like these split rings. So this will makes like always current to flow in the same direction now. Therefore, this is not fixed. This is just placed onto this one, no. So carbon brushes onto this. So we are going to just make in contact so that this it will be able to rotate, so that the current it will be able to remain same. Okay. So right now we'll discuss here what will be the force acting on this coil. So what will be the force? This is a force. It's a rotating. Rotating with means what it should experience a torque. So this side force, you know it, no, force is nothing but a B into I into length. Length of this one is L. So this is your breadth. So this part you try to observe, no, this part is along the direction of your magnetic field. It will not experience any force. The force it will be the zero of this part. So what will be the torque here now? Torque, you can rewrite it as force into perpendicular distance. You understand? Force into perpendicular distance. What is the force here now? B into I into L. If it is having n number of turns, no, n number of turns, this is only one wire is there, like that 100 wires are there, means 100, no, therefore into n, this is a force, clear? So why it's perpendicular onto this, into, therefore perpendicular distance is how much, no, therefore it's nothing but a B, correct? So what I can rewrite it now, n into I into B, therefore L cross B, I mean L into B. So L into B is nothing but area. So torque, what is the magnitude of the torque? No, N into I into A into B. Clear? So N into I into A into B. So therefore here, so N into I into A is nothing but a magnetic moment. Torque is equals to magnetic moment into B. So if you want to write it in a vector form onto this one, no, so you can rewrite it as M cross B. So will be your torque. What is the direction of your torque? No, M cross B. Therefore, M cross M is nothing but what? This is a current. So this side it will be your magnetic field. Magnetic moment is in this direction now. So B is in this direction. In this direction. So what is the torque here now? B is in this direction, magnetic moment is in this direction. What is the torque now? M cross B. M cross B. So therefore the torque will be acting in this direction onto this. That means it will be acting along this rod onto this. Clear? So we know that torque, it will be perpendicular to this one. No? Torque dot M, it will be equal to 0. Torque dot B, it will be also equal to 0. So if you want to have maximum torque, no? So this is your maximum torque, right? Why? Because M cross B into sin theta. So therefore maximum it will be equal to N into I into A into B. So therefore this is your maximum torque onto this one. Clear? So in this way we can convert this current into mechanical energy, right? So we can make it into like a mechanical energy, so that this motor, it will be able to rotate. We can convert electrical energy to the mechanical energy. Okay students, so some more applications are there on this one. No? So like even some numerical questions also we will do, like some more parts, 2 to 3 parts. Now again we will do it, no? So that all the questions, different varieties of questions, no, can be covered for the exam purpose. Right students, so we will see one more concept, no, that is work done in rotating the coil now, right? So work done, what is the work done now? Therefore work done in rotating a coil. What is the work done now? You can write down. So work is equals to, what is the rotational work is done now? So work is equals to integral tau into d theta. So torque, therefore work done from theta 1 to theta 2. What you can write now? Torque is nothing but a mb into sin theta into d theta. Therefore you can write it as theta 1 to theta 2. Clear? So mb, integral of this one, therefore mb into minus cos theta. So theta 1 to theta 2. Therefore you can substitute here now. So mb into theta 2, therefore theta 1 minus of minus, therefore cos theta 1 minus cos theta 2. So this is the work done in rotating a coil from one angle to another angle. You understand? So here suppose if it is rotating from, so theta is equals to theta 1 is equals to 0 to theta 2 is equals to theta. Therefore what you can write it now? Work done in rotation, no? Work done, it will be equal to mb into cos 0 is nothing but 1 minus cos theta. In this way, so we can rewrite it as work done in rotating from 0 degrees to theta degree. So here this rotating coil, no, therefore it will be having certain amount, energy, potential energy. We want to calculate potential energy. Potential energy is nothing but what? So potential energy is nothing but like a, you should know reference point onto this. So where low potential or zero potential is there, from there, so we need to calculate the work done now, right? So in this one, no, what you can rewrite it down? So we'll see, right? So what is the potential energy stored in this one now? Potential energy means you should know perfectly zero potential now. Where is the zero potential? Theta 1, it will be equal to 90 degree. So theta 2 is equals to theta. Therefore substitute now work done. Therefore it is nothing but a, so it will be nothing but a mb into cos 90 minus cos theta. Cos 90 is 0. So therefore this it will be the potential energy minus mb into cos theta. Clear? So u is equals to minus m dot b. This is most important formula. Most of the times no questions are coming from this, right? So when the potential energy will be maximum now, you can rewrite it as potential energy is maximum. So here when the potential energy will be maximum now, therefore potential energy is maximum. So when it will be, so that is nothing but a plus mb should be there. What will be the plus mb now? Therefore here theta. So theta should be equal to, therefore here cos theta should be equal to minus 1. Minus 1 means when it will be there 1 minus 1 no. So minus 1 cos therefore 180 degree. Theta is equals to 180 degree. So therefore potential energy will be maximum, right? When the potential energy will be minimum now, potential energy is minimum. So you can rewrite it as therefore minus mb, correct? So therefore here cos theta will be equal to 0, that it will be 1. So that is nothing but a cos 0. Therefore theta is equals to 0 degree. Clear? So 0 degree. So you try to remember that when it will be the stable equilibrium and unstable equilibrium. These type of questions no frequently asked in the examination no. So remember one point equilibrium concept if you take it no equilibrium. Potential energy you know it. What is the formula? F is equals to minus dou u by dou x. Correct? So when it will be the equilibrium no equilibrium means force it will be equal to 0. So stable equilibrium and unstable equilibrium. Remember always one point no, that is stable equilibrium means potential energy will be minimum. Unstable equilibrium means what? Potential energy is maximum. Therefore, if this coil is in this situation now, that is said to be stable equilibrium. So potential energy is minimum is nothing but a stable equilibrium. Potential energy is maximum is nothing but a unstable equilibrium. It is so unstable equilibrium now. Right? So now unstable equilibrium, right? Unstable equilibrium means what? If you give small disturbance no, automatically it will be able to get disturbed. So again it will never return back to the same position now. So stable equilibrium means what? If you slightly disturb also, again it will be able to oscillate, again come back to the original position now. That is said to be like a stable equilibrium now, right? So here when it will be there now, let us see here now. So here there is a coil is there. Suppose here this side it will be a magnetic field is there no, magnetic field theta should be equal to 0. So what is the theta should be equal to 0? Therefore here there is a one coil is there now. This coil having the magnetic moment in this direction, magnetic field is in this direction no, theta is equal to 0. So therefore it will be having minimum potential energy onto this. So suppose here there is a one magnetic field is there no, this is a magnetic field. So there is a one coil is there no, this one coil. So here magnetic moment in this direction no. So magnetic field is in this direction no, theta is equals to 180 degree. Easily if you are able to disturb it no, definitely again it will be able to rotate, again come back to the stable onto this. Clear? So in this way you can able to identify stable equilibrium and unstable equilibrium. We will do one numerical question, numerical part onto this one no, like some more 2 to 3 videos now I will bring back, so that you can able to do more questions on this, right? So you can become perfect onto this, so by watching all these videos now. So before coming to that numerical part of this one, no, please go through all these part 5 or 6 or 7 videos are there. So please try to go through it thoroughly so that you can understand clearly. Thank you for watching. Please subscribe to my channel now.